show you how to perform calculations concerning usual probability distribution, the normal, the binomial, and the student, also called the t-distribution. So we start with the binomial. Imagine we have a football club with 30 players, among them 20 locals and 10 foreigners. We pick at random with replacement a player 10 times, and note picking a local player as a success. So we wonder what is the number of possible scenarios to get 4 local players, which means 4 success. What's the probability of having exactly 4 players? What's the probability of having at most 4 players and at least 4 players? So we start by setting the parameters. We have the global number n equals 30. The number of success, which is the number of local players, 20. So the probability of success would be k divided by n. So for the number of success, we note first the number of trials, nt equals 10. The targeted value, kt equals 4. So the number nb would be got using the function choose. The first argument is the number of trials, and the second the targeted value. So there is 210 possible scenarios to get 4 success. So, to calculate the probability of having exactly 4 players in 10 trials, first, the probability of success in one trial is p power kt times 1 minus p power nt minus kt. And to get the whole probability, we multiply by the number of scenarios. So we call it P4. So P4 equals 5.6%. Another function, we can use another function which is dbinom, but first we need to load the required packages. Stats and stat4. So we make the same calculation using dbinom. The first argument is the target value, the second the size, the number of trial, and the probability of success. So dbinom, the target is kt, the size nt, and the probability is p. So we call it p42. So p42 is 5.6%, the same as this one. So to calculate the probability of having at most 4 locals and at least 4 locals, we use we call it at most 4 equals sum of the binom. The first argument is the range. At most means between 0 and 4. The size nt, and the probability p. So at most 4, it's 7.6%. Now at least 4. So the same function, but instead of between 0 and 4, it will be between 5 and 10, the remaining values. So nt and p. List 4. It's 92%, and if we sum the two values, since the events are complementary, we should get 1.